This standard is ARCH.8.EE.B.6.8.2d. The learning target, I can derive the equation y equals mx plus b. Remember in the last lesson we had y equals mx, but that only happens when the line goes through 0, 0. If the line doesn't go through 0, 0, then b is where the line goes through on the y-axis. So we have to account for the fact that lines don't always go right through 0, 0, and that b is that piece of the equation that takes care of that. To derive this equation, first observe two similar triangles can be made along this line. You can make an infinite number of similar triangles along the line, but right now we're just looking at two. They're similar because they're the same shape, but not the same size. Similar triangles will have the same slope because they have a proportional relationship. Remember, the slope is y minus y, also called the rise. We want to know how far we're rising. Even if we're going down, that's still called rise. And then run is whether we move to the right or to the left. So that's our x-axis. So the first triangle here, we have the rise, as you can count how many squares. It's just one square over one square. So the first triangle has a slope of 1. The second triangle here, you can see if we count from this point, 1, 2, 3 up, 1, 2, 3 over. So the rise of 3 over the run of 3 still gives you a slope of 1. So we've proven so far that they do have the same slope. Now what we're going to do is change this distance from 1, and we're just going to call it m, as if we didn't know what this amount of rising was. So we're going to say the slope of the first triangle, the rise is m, and then we're going to say the run is 1. So we do see that is 1 unit, and we're going to go with that. And then we're going to set it equal to, because it's a proportional relationship, we're going to define this triangle as rise over run a little differently. We're going to say the rise, well, starting from 0, the rise all the way up to here is y, but this triangle does not include this piece, this triangle here. So this line we want, this rise from here to here, this piece of the triangle, from here to here, is really y minus b, because this distance is b, and then this distance is y minus b, because this whole thing would be y, remove the b, and you're left with y minus b. So that's the rise here. Then this run, we're not going to call it 3, we're going to call it x, because it is on the x-axis. So now that we've set these two equations equal to each other, because we've redefined the rise over run here and here, we can move forward with this on the next page. Since we said y minus b over x equals m over 1, and I do realize that all I did was switch places. I just put the y minus b over x on the left side, and I put the m over 1 on the right side, because ultimately we want to solve for y. So you're going to multiply both sides by x to eliminate it from the denominator. So you have y minus b over x times x, and then to keep it a balanced equation, you multiply this side by x. So now you've eliminated the x, you have y minus b equals x times m. Now you add b to both sides. So you currently have y minus b, and you're going to add b to get rid of it. So you're going to add b to this side also. This way you've eliminated the b. You just have y equals, you still have xm, but traditionally we write the m first, so we'll just switch places because multiplication allows that, and then we're adding that b. So we just derived the equation of a line, which was our learning target. Y equals mx plus b. So your slope is change in y over change in x, and then b is where the line slices into the y-axis. Just a quick sketch. If you had a line like that on your graph, this point here is b, also called the intercept on the y-axis. So the large triangle, y equals mx plus b, if you want to input numbers to see if it's true, then if you say that y is equal to 6 and the slope is equal to 1, x is equal to 3 over 3, start it here and went up 6, and we said the y-intercept is 3. 1, 2, 3. Does 6 equal, does y equal the slope times x plus b? Does 6 equal 1 times 3 plus 3? Yes, it does. And that is the end of this lesson.